look at equivalent ratios and proportions. Ratios are just a comparison. Alright? If we want to compare, say, the number of blondes to the number of brunettes in a high school setting, there may be, for every 2 blondes, there are 5 brunettes. Okay? Sometimes that also can be expressed as 2 to 5. Okay? I much prefer expressing it as a fraction because it's easier to work with, right? We use ratios in order to extrapolate and to come up with solve problems. So, like, say for example, I know that the ratio of blondes to brunettes is 2 to 5 in the high school, and there are say 15 brunettes in my classroom. I will want to calculate how many blondes there would be expected to I would find. I would go there. The ratio is 2 to 5 blondes to brunettes, and that would be equal to a certain number of blondes to 15 brunettes. When we compare 2 fractions to each other, or 2 ratios to each other, they're said to be called proportions. Okay, so in this case, we're looking to solve for x, right? When we're looking to solve for x, our goal, remember, is to get x all by itself. So we end up with a number equals x, a single number equals x. Well, in order to do that, I have to get rid of a divided by 15. X over 15 is x divided by 15. That's where that divided by sign comes from, right? And number over number, right? So I want to get rid of a divided by 15. Well, how do we get rid of a divided by 15? I do the opposite of a divided by 15. I multiply by 15. Now remember, an equal sign is like a teeter-totter. Okay? If I've just thrown on a times 15 onto one side of the teeter-totter is going to go yoink. So the rule is, whatever you do to one side, I have to do to the other. So if I multiply by 15 on the right side of the equation, I have to multiply by 15 on the left side of the equation. Alright, so the multiplying 15 gets rid of the divided by 15, leaves me with my x, so I write my x down below. Okay, on this side, I go 15 times 2 is 30, and then over 5, or divided by 5. I can now solve. 30 divided by 5 is 6. Okay, so using the ratio 2 to 5, I can extrapolate that if I had 15 brunettes in my classroom, I would expect to have 6 blondes. Okay, let's do another example. Get rid of that. Okay, what if I had x over 5 equals 4 over 20. Okay, I know that my ratio is 4 to 20. I want to extrapolate down to figure out what my ratio would be, something out of 5. Okay, again, goal is to get x by itself. So in order to get rid of a divided by 5, I multiply by 5. Whatever you do to one side, you do to the other. Multiplying 5 cancels out a divided by 5. Leaves me with my x on my left side. I'm done on that side. Left side's done. Let's go to the right side. 4 times 5 is 20 over 20. Alright, well, cancel the zeros. 2 over 2 is 1. Now, what if I had the x down below? What if I had 3 over 2 equals 15 over x? Well, to make it real easy for yourself, get that x upstairs right away. In order to do that, just flip it. Alright, so if I take that x over 15 and I flip it so it becomes x over 15 as opposed to 15 over x, I can do that as long as I do it to the other side, because whatever you do to one side, you can do to the other. So if I flip a fraction on the right side, I have to flip the fraction on the left side. So 3 over 2 becomes 2 over 3. Okay, now my x is upstairs. Now it's easy to work with. How do I get rid of a divided by 15? I multiply by 15. Whatever you do to one side, you do to the other. Multiplying 15 cancels out a divided by 15, leaves me with my x on my right side. Right side of the equation is now solved. On the left side, I have 15 times 2 is 30. Don't forget over the 3. 30 divided by 3 is 10. Okay, let's do another one. What if I had, in this case, what if I had 3 over x equals 6 over 14, which was also proportional to something, y over 28. This is a little different because now I'm dealing with 3 fractions. Well, let's just deal with 2 fractions at a time. So let's just deal with these 2. Now my x is downstairs, let's get it upstairs, so I'm going to flip it. So 3 over x becomes x over 3. Whatever I do to one side, I must do to the other. So it becomes 14 over 6. I multiply through by a 3 to get rid of a divided by 3, and whatever I do to one side, I do to the other. Multiplying 3 gets rid of a divided by 3, leaves me with my x on my left side. My left side of the equation is now solved. Let's go to the right side. 14 times 3. Well, 3 tens is 30, and 3 fours is 12, so 12 and 30 is 42 over 6. X equals 42 divided by 6 is 7. Okay? Now let's solve for these 2. 6 over 14 equals y over 28. I want to get rid of a divided by 28, so I multiply through by 28. Whatever I do to one side, I do to the other. And multiplying 28 gets rid of a divided by 28, leaves me with a y, which is what I want, all by itself. Right side is solved. Now on the left side, I got 28 divided by 6, or times 6. So we'll go to a calculator, and we go 28 times 6 gives us 168. So 168 over 14. That's a divided by sign, right? So let's go back to the calculator. 168 divided by 14 gives me 12. So 12 equals y. So in this case, x is going to be 7. I'm going to end up with 3 over 7 equals 6 over 14, which is going to equal 12 over 28. There you go. Equivalent ratios and proportions. Keep it simple, right? Get that unknown upstairs and then just start multiplying through.